The largest unreinforced concrete dome on the planet was poured 1900 years ago, and every attempt to explain how it is still standing leads to the same uncomfortable conclusion. No steel reinforcement, no computer modeling, no industrial mixing equipment. The Romans poured it once, in layers, using a recipe that modern engineers spent decades trying to reverse engineer and largely failed to replicate. One number puts this in perspective. The Pantheon dome spans 142 feet across. It was completed in 125 AD for the next 1,300 years. No civilization on Earth built a larger dome. Not the Byzantine Empire, not the Islamic caliphates, not medieval Europe. The question is not whether this is remarkable. The question is what it means when you examine 4 structures across 3 continents and find the same pattern repeating. What's coming will shift how you see reality. Make sure you don't lose access. Hit subscribe. The standard explanation for ancient engineering achievements is comfortable and familiar. Ancient builders had unlimited labor, unlimited time, and a tolerance for failure that modern construction cannot afford. That explanation works as long as you don't run the actual numbers. When engineers do run the numbers, when they apply modern load analysis, materials testing, and hydraulic modeling to what survives, the comfortable explanation stops working. Not because the results are mysterious, because they are specific. The structures performed at a level that the documented knowledge of their time does not account for. You grew up in an era when American engineering put men on the moon and built the interstate highway system. You know what organized technical knowledge looks like when it produces results. What you are about to see is something that looks identical, but has no known origin. 4 cities. 4 civilizations. 4 impossibilities. The journey begins in Rome. The concrete inside the Pantheon dome is actively healing itself, and a study published by MIT and the University of California in 2023 confirmed that Roman engineers built that mechanism into the mix on purpose. That finding rewrites something. For 2 centuries, the standard explanation for Roman concrete's longevity was passive. The volcanic ash from the region of Pos happened to produce a durable mix, and the Romans were fortunate in their geography. The 2023 analysis dismantled that explanation at the chemical level. What the MIT team found inside the Pantheon's walls were lime clasks, small white chunks of calcium carbonate distributed throughout the concrete matrix. For decades, archaeologists assumed these were manufacturing defects, signs of impure mixing. The 2023 study showed they are nothing of the kind. Stop and translate that into physical reality. When a hairline fracture forms in the concrete, as it inevitably does over centuries of thermal expansion and contraction, water enters. The water reacts with the lime. The reaction produces new calcium carbonate crystals. The crystals fill the crack from the inside. The concrete reseals itself. That is not geology. That is engineering. The lime clasks are not accidental impurities. They are precisely distributed throughout the matrix, which means someone understood what they were for. Now consider the structure they protect. The Pantheon dome spans 43.3 meters, 142 feet, at its widest point. It rises to a height of 43.3 meters as well, creating a perfect sphere from floor to oculus. That oculus, the open circular eye at the crown, is 8.9 meters across. It is unglazed. Rain enters through it when it rains. For 19 centuries, water has been entering through that opening, running down the interior and being managed by a drainage system that still functions. The dome, in those same 19 centuries, has not developed a single primary structural crack. The weight of that dome is approximately 5 million kilograms, roughly the weight of 3,500 average American automobiles, suspended overhead. Modern engineers analyzing the structure have identified something counterintuitive. The Romans used lighter, pumice-based aggregate, near the top of the dome and heavier basalt aggregate. At the base, the density gradient reduces the load precisely where the structure is most vulnerable to collapse. The irony here is worth sitting with. A 2023 MIT laboratory, equipped with electron microscopes and X-ray diffraction analysis, spent months confirming what a Roman engineer understood well enough to bake into a concrete recipe in 125 AD. We know what they did. We have now confirmed it scientifically. What we do not know is how they knew to do it. What body of knowledge, what chain of experiment and observation produced that recipe? That question becomes more uncomfortable when you travel east to Lebanon and stand in front of 3 stones that should not exist. In 1977, a team of engineers commissioned by the Lebanese government calculated the weight of the largest stone at Baalbek and stopped the study. The number -1,650 tons placed the task outside the boundary of what they could model with available equipment. Baalbek sits in the Bekaa Valley of Lebanon at an elevation of approximately 1,170 meters above sea level. The Romans built a temple complex. They're dedicated to Jupiter, and it is among the largest religious structures the Roman world ever produced. But beneath the Roman construction, serving as its foundation, are 3 stones that predate the Roman presence entirely. They are called the Trilithon. Each stone is approximately 19 meters long, 4 meters high, and 3.5 meters wide. The smallest weighs approximately 800 tons. The middle weighs approximately 1,000 tons. The largest, the one the 1977 engineering team stopped calculating, weighs 1,650 tons. Translate that into something you can stand next to. The largest stone at Baalbek weighs more than the fully loaded space shuttle at launch. It is larger than 3 city buses placed end to end. It was cut from a limestone quarry approximately 1 kilometer from its current position, transported to that site, and lifted to a height of roughly 8 meters to be placed as a foundation stone. The conventional explanation invokes ramp systems and organized labor, thousands of workers pulling in coordinated teams using wooden rollers and ropes. Archaeologists and engineers have modeled that scenario repeatedly. The problem is not the pulling. The problem is the ramp. To move a 1,650-ton stone up a ramp to a height of 8 meters, the ramp itself would need to be enormous by engineering calculation, approximately 80 meters long, with a corresponding volume of fill material. That ramp would have been, by itself, one of the largest construction projects in the ancient world. It would have left stratigraphic evidence in the soil visible in every comparable excavation site. No such evidence exists at Baalbek. What does exist is something discovered in 2014, approximately 800 meters from the temple platform, still lying in its quarry bed. Archaeologists working under the auspices of the German Archaeological Institute found a stone that had been cut and partially shaped and then abandoned. Its weight, 1,650 tons, identical to the largest trilithon stone. Consider what that means. This was not a one-time achievement. This was an ongoing operation. The quarry contained at least 1 additional stone of the same scale, already in preparation when the project was interrupted. Whatever civilization was moving these stones had developed a repeatable process for doing so, organized enough to be running in parallel at multiple extraction points. That process has no documented explanation. No engineering manual from the ancient world describes it. No archaeological record captures it in progress. The stones exist, placed with millimeter-level precision against each other, and the method that placed them has left no recoverable trace. The Romans, who built on top of this foundation, did not build the trilithon. Roman engineers were sophisticated enough to recognize a foundation they could not have laid themselves, and chose to build on top of it, rather than attempt to replicate it. There is something worth pausing on in that choice. But what comes next makes even this seem ordinary. In 2024, a team from the University of St. Andrews, excavating directly beneath Petra's treasury, the most famous facade in the ancient world, found a sealed crypt containing 12 skeletal remains, buried artifacts, and evidence that changes the treasury's purpose entirely. The treasury has been visible to the modern world since 1812, when Swiss explorer Johann Ludwig Burckhardt rediscovered Petra after more than 1,000 years of Western ignorance of its existence. For 2 centuries, archaeologists debated whether the treasury was a royal tomb, a civic monument, or a religious temple. The 2024 excavation did not settle that debate. It deepened Italiano. The 12 individuals found in the crypt were buried with artifacts consistent with elite status. The crypt was sealed deliberately and permanently at a date that appears to predate the treasury's most famous period of use, which means the building was constructed around and above a burial that already existed, or the burial was placed there during construction as a foundational act. Either interpretation raises a question about purpose that no existing Nabataean text answers, because here is what you need to understand about how Petra was built. The treasury and the hundreds of other structures carved into Petra's rose-red sandstone cliffs were not assembled. They were removed. The builders began at the top of the cliff face and carved downward, completing the decorative ceiling before the floor existed, finishing the upper facade ornaments before workers could stand at ground level inside the structure. Stop and hold that image. To carve a building top-down means the architect held the complete design in working memory, or in some form of planning document, before the first cut was made. There was no ability to revise the ceiling once the walls were begun. There was no ability to adjust the proportions of the upper colonnade once the lower facade was carved. The entire structure existed as a plan before it existed as a building, and every cut was irreversible. The precision of those cuts, across hundreds of structures spread over a city covering approximately 264 square kilometers, argues for a standardized system of measurement, transmitted consistently across a workforce operating at scale. And then there is the water. Petra sits in a desert. Its annual rainfall averages less than 4 inches. At its peak, the city housed approximately 30,000 people. Those people survived on a hydraulic infrastructure that the Nabataeans carved entirely from sandstone. A network of channels, settling tanks, and ceramic pipes that collected, filtered, and distributed water from flash floods and seasonal rains throughout a city the size of modern downtown Indianapolis. Hydrologists studying the system have found that the Nabataean engineers accounted for the rates of desert flash floods, designing settling chambers at specific intervals to prevent the distribution pipes from clogging. This is not improvised. This is calculated hydrology, applied consistently across a system that served tens of thousands of people for approximately 600 years. Petra was then abandoned. Around 663 AD, the city's population dispersed. The location was not recorded in any Western document of sufficient circulation to remain in common knowledge. For more than 1,000 years, one of the most sophisticated cities the ancient world produced was, to the outside world, simply gone. We found it again. We are still learning what it means, but the most unsettling part is still ahead. The Church of St. George at Lalibela is a perfect cube of volcanic basalt, 15 meters on each side, carved straight down into the earth, and according to carbon dating, it was completed within a single generation. Lalibela is a town in the highlands of northern Ethiopia at an elevation of approximately 2,500 meters. In the late 12th and early 13th centuries, 11 monolithic churches were carved there from the living rock, not built from stone, not assembled from quarried blocks, carved, removed from the surrounding mass, leaving freestanding structures connected to the bedrock only at their foundations, surrounded by open trenches cut to create walls of air between the church exterior and the cliff face. The critical word is monolithic. A monolithic structure is one continuous piece of material. There are no joints in the walls of St. George's Church, no seams in the ceiling, no place where one block meets another. The entire structured roof, walls, windows, interior columns, floor, is a single unbroken piece of the original volcanic plateau, which means there was no margin for error at any stage of the carving process. A miscalculation in the roof thickness could not be corrected by replacing a damaged block. A wall, carved too thin, had no repair. The entire structure was committed from the first cut. Translate that into what it requires. Before the first stone was removed, the complete interior geometry of every room, every window aperture, every column diameter had to be resolved. The carving proceeded from outside to inside, exterior walls first, interior spaces second, and every measurement had to be held with sufficient precision that the finished interior matched the original design. Beneath the churches, the Ethiopian Heritage Trust has documented a drainage system of channels and sumps that has managed rainfall on the volcanic plateau for approximately 8 years without allowing any of the 11 churches to flood. That system required survey-level planning before the carving began. The drainage channels run beneath the finished floors, which means they were designed and cut before the interior of the churches existed. The official historical record attributes the construction to King Lalibela, who reigned approximately 1181 to 1221 AD, and credits divine instruction for the design. The carbon dating is consistent with that reign. The engineering knowledge required to execute the drainage system, the monolithic carving sequence, and the structural load calculations for 11 separate freestanding rock-cut buildings. That knowledge has no documented source in 12th century Ethiopian records. 4 structures, 4 continents, 4 civilizations, with no verified contact with each other. The same pattern, a level of engineering knowledge that exceeds what the historical record of that civilization's development would lead you to expect. That pattern requires an explanation. The comfortable interpretation is that we are simply missing documents. Libraries burned. Papyrus decayed, stone tablets were repurposed as building material. The engineering manuals that guided the construction of the Pantheon, the Trilithon, the Nabataean hydraulic system, and the churches of Lalibela existed once and no longer exist. That explanation is plausible, and it is probably partially correct. But the scale of what is missing argues for something more than document loss. What these 4 sites demonstrate is not advanced effort. Effort is visible in the archaeological record, in the waste stone around Lalibela, in the tool marks on Petra's cliff faces, in the Roman construction accounts that survive in partial form. What is absent is not evidence of the work. What is absent is evidence of the learning. Every engineering tradition in the documented historical record shows a developmental arc: early failures, structural collapses, iterative refinement, gradual improvement across generations. Roman aqueduct engineering shows this arc clearly. Medieval cathedral engineering shows it. The Pantheon's concrete recipe, the Baalbek foundation stones, the Petra water system, and the Lalibela drainage channels show no such arc in the records that survive. Consider what the MIT findings on Roman concrete imply. The self-healing mechanism in the Pantheon's mix requires knowledge of pozzolanic chemistry at a level of practical understanding that the Roman engineering texts that survive do not describe. Vitruvius, the most comprehensive Roman engineering writer whose work remains, describes lime and volcanic ash as useful building materials. He does not describe the self-healing mechanism. Someone knew more than Vitruvius recorded. Stop and weigh that. The knowledge existed. It was applied at scale. It was not written down in any surviving form, or it was written down and the writing did not survive across all 4 sites. In 4 separate civilizations, the pattern is identical. The product of the knowledge exists and the transmission of the knowledge does not. Researchers at MIT, the German Archaeological Institute, the University of St. Andrews, and the Ethiopian Heritage Trust are, at this moment, working with what the structures themselves can teach. The structures are generous informants. They have been standing in some cases for nearly 2,000 years, holding information that no library preserved. The question is, what we do with what they are still telling us. What connects the Pantheon, Baalbek, Petra, and Lalibela is not mystery in the popular sense. Not the mystery of the inexplicable or the supernatural. It is a more specific and more interesting kind of mystery. It is the mystery of knowledge that existed, produced results at the highest level, and then stopped being transmitted. That is not ancient history's failure. That is a human pattern. We have watched it happen in living memory. Technical knowledge that lived in the minds of craftsmen, in the hands of practitioners, in oral traditions that modernization interrupted. The knowledge of how to build a wooden sailing ship to open ocean standards. The knowledge of how to tan leather using specific plant compounds. Entire technical lineages ended within a generation, leaving only the products behind. What the ancient world lost was simply larger in scale. Imagine a Roman engineer standing inside the Pantheon on the day it opened, 125 AD, looking up through the oculus at a circle of sky, knowing precisely what he had built and why it would last. 19 centuries later, a laboratory in Cambridge, Massachusetts, is still working out the details of what he knew. The stones are still there. The knowledge that placed them is not. The investigation doesn't stop here. Subscribe so the next chapter finds you.